Hello everyone. So today the problems I solved were from the binary tree miscellaneous. So these six problems. So let's have a quick overview of these problems. Other than that, the brain stealer puzzle, devil's penny. So this is an interesting problem. Don't miss this. I was not able to solve this, so you should definitely check it out. And this one is kth largest element in a stream. Okay, we know that when there is kth largest concept, generally we heap, use heap to of size k, and kth largest and smallest we can read from there. This is also a similar problem, entire same, but the k constraint we have, the size of the heap, uh, basically there was a edge case kind of thing. So we need to handle that. Let's say basically what we were doing, we were inserting the values into the heap from vector. So let's say the here we want fifth largest element, okay, and the vector size is 4. Here's a its condition: nums length plus 1 equal to k. Let's say nums length is equal to 4 plus 1 5. So when the nums length is equal to 4, let's say we have inserted all the element in our priority queue. So there is one more space. Okay, so basically at that time I inserted like int min only. Okay, because when we are performing this operation and in val, I just simply wanted to check like if priority queue top is less than val, then insert it and pop. So to ensure like uh, this part is smooth and easily solvable, so I did this part. So this part was interesting. Other than that, this is very easy, like you can easily do it. This is the same exact problem like the previously I discussed, using a priority queue of size k. If size is k, keep pushing. If size is equal to k, then check if the value is greater than top, then pop and push it. Okay, and this was a problem: count distinct elements in every window. I used a unordered map to solve it. Okay, so problem is very easy, you will also able to solve it. I was a bit confused that can we use map.size to get the size of the map, like number of keys. So yeah, we can definitely get it. But when I first submitted this code, let me uncomment this. When I ran this, I got an error. You will see we were getting basically an error. Okay, so this was due to, let's say, when the value of the key was becoming 0, we were also calculating that part also. You will, when you will try, you will see that. But when the value becomes 0 for a particular key, we don't want to calculate it, so we have to delete that. So map.erase array of j, array key, basically key, if value of key becomes 0. So this I figured out after using some dry run. Like after when I got this wrong answer, I used pen paper and figured this out. So this shows the power of dry run. So definitely add, we must do so to this. Okay. So the next one is flood fill. This is also, I won't say difficult, easy side. We basically are given an image pixel. So and this was the our image 2D vector. We were given some I and j initially. Let's say this is our I comma j first, 1 comma 1. So and we have to replace the original color with some new color. Okay, let's say we have old color at this position, some SR and SC IJ, and we have the new color, this new color. So you have to check if the new color is same, we don't need to do anything, but if there is different, we need to do some manipulations, so we can say some operations. So the operation are basically, let's say here it is 1, we have to go vertical and horizontal, and if the value is 1, then convert it to the new value. Let's say we are changing 1 to 2. Okay, so first convert 1 to 2, and also go horizontal and vertical. Like this is horizontal and vertical having the same side, like only one vertical up, one vertical down, one horizontal left, one horizontal right, and check if it is also one like same original color, then change it to 2. Let's say, see example, for example, from here we want 1 to 2, and we check, okay, this is also 1, make it a 2, this is also 1, make it a 2. We won't go this, we'll check it later. Okay, now we have done this. For this is horizontal, so convert it to 2. Like kind of recursion, you can say a recursive form. I did the same here. I just defined initial some variables to make things simpler. max row max column, and just let's say I change the initial color, and I check that if I plus 1 is within the range, and if that color is original color, let's say at this position it's original color 1, so just change the color. And also this part was simply a recursive call. Okay, and there was no need for the base case here, because the this function was called only if this was within the range, and this was also case. So basically we are already constraining our recursive call, so the code will all ultimately die out. So this is the very famous problem: find the median from a data stream. We use the min and max heap concept here. Min and max heap. Okay, I solved it before, so I didn't solve it today. I already had the solution, and I don't want to try it out again. So basically, suppose we had to add a number, adding a new number. So what would I say? Let's see if our max heap is empty, or the value we are adding is less than the max heap top. So keep into max heap, else put into min heap. And after adding them, we just need to balance the size of both. And we want to ensure that the median goes into max heap. So the max heap size should be greater than min heap size plus 1. Plus 1 because we want to keep like odd number of, let's say there are 7 values till yet. We want 4 values in max heap, 3 in min heap. And why so? Because we want to keep the median in the max heap. Okay. Instead median max stays on the max heap. So if the size is more than that, we need to push, like remove the element. So min heap dot push, remove the top element of the max heap top, and just pop it. And for the, if min is greater than max heap, just check there's not plus 1 here. Just think of it, you will find the solution, like why I'm saying so. So then pop from the min heap. And for getting the median, let's say both are of equal sizes, then just do the average. Both are equal sizes, simply do the average. If they are both are not unequal sizes, let's say total is odd, you can simply pick the top of the max heap. I give the example of, let's say there are 7 elements, and we are actually ensuring by ourselves only that 4 are in max heap and 3 are in min heap. You can simply do so. Okay, and this problem I was not able to solve. Actually, I was trying to do using some kind of like some change. I want to make some changes in voice traversal, like iterative approach, but I looked for solution in iterative approach, though it went very like become very lengthy. So later I came to recursive approach, and so this is it. Simple as let's say you will make the left call, right call, and while doing the in order part, you did some, let's say write some code. We define some head basically head of our linked list, double linked list, and previous, this is all basically the iterator which will be moving. So if the previous is null, we are starting out, so keep the head as root. Else previous right is equal to root, and root left is equal to previous. Right and left we are ensuring. This is a double linked list. And when they are moving the previous to root, this is simple if you use the recursive concept. But if you want to go through iterative, things will be interesting or lengthy, bit difficult. This is saying hard, but if you go by recursive, things will be very easy. Okay, that's it for today. Our next, I I will need some time here, because I have to start graph. Okay, on 20 problems from graph and then DP. Okay, try is also there. Okay then, bye bye till then. Keep solving the problems, here. There is no other way.